Hello everyone, welcome to lecture 19. This is the first lecture of module 6 and today we will start the cryosphere. So in the initial phase we will try to understand what do we mean by cryosphere, why it is important, and slowly we will get into the hazards related to cryosphere. So let us start. So to understand the cryosphere we need to know about the hydrosphere, right? So hydrosphere is the earth's blanket of water and ice. So it has both component, water and ice. And if you see the origin of this hydrosphere, so it is from a Greek word. So here it is hydor and sphaira, right? So hydor means water and sphaira means the globe, ball or sphere. So together they make this hydrosphere, right? When we talk about the water available on earth, so here we see that only 2.5% of the earth water, that is the fresh water, and 97.5% of the water belongs to ocean, right, which are not potable. Now out of this 2.5%, we have this 74% belongs to cryosphere. It is basically frozen fresh water, and rest 26% is the unfrozen fresh water. If you see further division, the 26% of fresh water, here out of 26%, 98.5% belong to groundwater and rest is the surface water, right. And from this surface water, we have atmosphere, soil moisture, surface fresh water in terms of lakes, stream. So this is our biosphere, right. So here the important thing is the 74% belongs to the cryosphere. So you see the huge amount of water which is stored in cryosphere is very important to survive on this particular planet. The cryosphere, when we say, it is basically Earth's cover of snow and ice. Here again it is from a Greek word cryos and sphaira. So this is one photograph. I have used this photograph here to show the water present in the three forms, right. So you can see some of the example. Here water is present in all the three forms, right. So let us understand one by one what is cryosphere, what do we mean by cryosphere. So the cryosphere refers to all frozen water on earth including ice, snow and permafrost, right. It plays a crucial role in Earth's climate system. So here you can see this is a typical representation of cryosphere. Here you have ice caps, then you have snow and the glaciers are here, then lake and river ice are present here, some of the floating ice are present on the ocean, then we also have ice sheet and on top of that you have snow cover, right. So this is the typical representation of cryosphere. Now what are the different components of cryosphere? So the first one is the glacier and ice caps, then we have ice sheets which is basically Greenland and Antarctica, and snow cover, sea ice, permafrost, icebergs, ice shelves, seasonally frozen grounds and solid precipitation. So when we talk about the normal precipitation, it is in the liquid form, but the solid precipitation is basically where snowfall is happening, right. Here you will understand the importance of cryosphere. So here you have ice sheets, here you have snow cover, glacier mass are present here, sea ice is present here, and together they are making this cryosphere. So why it is important? We will try to understand. So it is the freshwater storage. As we know, it holds about 76% of the Earth's freshwater in form of ice and snow. It also supports the ecosystem. It helps to sustain biodiversity by providing water to various ecosystems. Then we have water resource regulation. It supplies fresh water to major rivers, supporting millions of people on this planet. Climate indicator, because if there is a slight change in the climate variables, it will immediately impact the storage of the snow and ice. So, change in ice and snow serves as key indicator of climate change. Weather and climate influence, it affects the global temperature regulation, because a huge area belongs to cryosphere, right, and cryosphere is basically ice and snow, and these are highly reflective in nature. So, the solar radiation which is coming to the surface, it is getting reflected back because of this ice and snow, right. So, it is controlling or regulating the global temperature. Ocean currents and atmospheric patterns are governed by the presence of these cryospheric components. Livelihood support provides water for agriculture, hydropower and drinking needs, especially in downstream region, because if there is a fluvial system and here you have the glacier, so this will melt and it will feed the water into this river and it will reach to the downstream. Then the global impact, even remote cryospheric change affects sea levels and weather pattern worldwide. So, we have seen different aspect of cryosphere, how it is important in regulating the global temperature, how it is serving as the fresh water storage. So, these are very important for our survival on this particular planet. So, the key cryospheric regions, you can see the Antarctic cryosphere, right. So, here you can see the Antarctic cryosphere refers to the ice and snow covering the Antarctic continent, primarily consisting of the massive Antarctic ice sheets, which is the largest single mass of ice on earth, holding about 90% of the world's fresh water, right. It also includes surrounding sea ice and ice shelves. We will try to see what we mean by ice shelves and sea ice, and this is along the coastline. Rising global temperatures are causing concern about potential ice sheet melting and sea level rise. So, sea level rise is one of the important reason why we are bothered about the cryospheric components, right, especially in the coastal region of Antarctica. So, you see this is from this particular link, and here the most important thing that they wanted to highlight is the Antarctic ice sheet, which holds enough ice to raise sea level by 58 meters, faces irreversible melting as temperature increase, flooding coastlines up to 6 centimeter per year if current high emission continues. So, you can see how dangerous the situation will be if there is abnormal melting of the Antarctic glaciers, right. So, it can raise the 58 meter high sea levels, and you can imagine the situation in the coastal region, what will happen to those areas, right. So, here you have Antarctic and Arctic. So, these two areas. So, the Arctic cryosphere primarily consists of vast expanses of sea ice floating on the Arctic Ocean, with significant portion of land ice on the Greenland's ice sheet. It is characterized by extreme cold temperature, where most of the water exists in a frozen state. It plays a crucial role in regulating Earth's climate due to its high reflectivity. We also call it albedo of sunlight, right. So, this is what I said, if the sun is illuminating this area, what happens? This get reflected immediately, right, and because of this we are having less temperature on the surface. Otherwise, any other material other than this ice or snow, that will absorb the temperature, and then the global temperature will rise very soon. The Arctic cryosphere is rapidly shrinking, particularly in terms of summer sea ice cover, right. Here again there is a highlight. Arctic sea ice helps regulating global temperature. It both cools the Arctic and surrounding seas and reflects sun rays during summer. When it disappears, the dark ocean absorbs more heat, the Arctic entire ecosystem changes, right. So, the ecosystem of that particular area in the surrounding, that will be affected immediately, but as Earth it will also be affected. So, the key cryospheric region, that we have this Himalayan cryosphere, right. So, here if you see, the Himalayan cryosphere, often called the third pole, is a vast collection of ice and snow in the Himalayas, encompassing large glacier and permafrost areas, acts as a crucial source of fresh water for several major river systems like Indus, Ganga and Brahmaputra, impacting the livelihoods of billions of people across the region. This cryosphere is rapidly shrinking, leading to concerns about water security and potential natural disaster like glacial lake outburst flood. In the past few years, the incidences of globe has increased because of the more melting. So, climate is changing and it is impacting the Himalayan cryosphere as well. So, here you can see, the when we talk about the Himalayan glacier, we have Ladakh, then we have Jammu and Kashmir, then Uttarakhand, then Himachal Pradesh, Sikkim and Arunachal Pradesh. Together they make this Himalayan cryosphere, especially the Indian Himalayan cryosphere. So, we will try to understand what and how these glaciers are born, how these ice which is falling from the sky, they are getting accumulated and slowly they are getting converted into the glacier. So, in the first step, what happens? We have snow forms when water vapors in cloud freezes into ice crystal due to low temperature, right. Then it precipitates. When snowflakes become heavy enough, they fall to the ground as snowfall if the entire domain is having the low temperature. Melting and runoff. As temperature rise, snow melts into water, contributing to rivers, lakes and groundwater recharge, playing a crucial role in freshwater availability. Then another form is the densification into glaciers. In high altitude or polar region, persistent snowfall compacts under its own weight, turning into firn, the dense snow, and eventually forming glacier ice over time. So, again remember, I am calling it glacier ice, and slowly we will try to understand what exactly is glacier, when do we call it glacier, right. So, if you see here, this is one map that we have prepared from 1989 for the Sikkim Himalayas, and here how it is changing. The snow cover is changing with time. So, every year it is not consistent and slowly it is getting changed. So, we will discuss this in next few lectures, but for now we will focus on the glacier formation. So, the glaciers form when the snow has accumulated at a location year round and has transformed to ice. When the fresh snow falls, the previous ones are buried and compressed, which causes their recrystallization, right. So, there will be a recrystallization. So, here this is the loose snow, then you have granular snow, then we have firn, then we have fine grained ice, and then slowly we will have coarse grained ice, right. And if you see how much time they are taking in the nature, that is also given here. Eventually, ferns are formed, which is intermediate to snow and glacier, and over time when the air pockets are too low and the crystals are large enough, glacier ice forms, right. So, here you can see the different spectral behavior of snow. So, this is fresh snow, then we have fern, then we have recrystallized ice, glacier ice, and then dirty glacier. So, this is contaminated one. So, this is the difference between the natural and the refrigerated ice. So, here you see there is a difference between the glacier ice which is formed in the nature, and this is what we are freezing it in the refrigerator. So, if you see the different aspects, the formation, so here we are freezing, and then in the nature it is metamorphism. Age, here it is few hours to days, and here 1000 to millions of years. Structure, it is uniform and pure, right, this one, and here we can have trapped air and sediments. The density is less here in the refrigerated one, and here it is more denser. Appearance, clear to slightly cloudy, and here it is bluish white. This is thermal property, melts quickly, and here it melts relatively at slower rate. So, when snowpack grows thicker, now we have understood when there is a snowfall, slowly it gets packed and then metamorphism takes place and then they grow, right. So, amount of snowfall is greater than amount of melting in that particular area, that will lead to the increase in the snow depth, right. Subsequently, the deeper snow recrystallizes into denser ice under the increased weight of overlying snow, and due to gravity, thicker and denser snow and ice starts their movement, because we are talking about these accumulation at the high altitude region, right. And slowly, because of this weight, this will start their movement in the downstream because of the gravity, right. So, if this is the situation, then we say a glacier is born, right. A glacier is a persistent body of ice consisting largely of recrystallized snow, which shows evidence of slow downslope or outward movement under the influence of gravity. So, this is very, very important. We cannot call everywhere it is glacier. Glaciers are only when they have a movement under the influence of gravity, right. Glaciers vary considerably in shape and size. Depending upon the topography, they takes their or they acquire their shape, right. We have a very good inventory, so we call it Randolph Glacier Inventory. So, here all the glacier across the globe are compiled in the Randolph Glacier Inventory. It was developed by the IPPC and is now available at the Glimpse Glacier database, and it is available for public use. So, any of you, if you are interested in looking for a glacier body, and if you want, so mostly they have given the name, some of the glaciers are having no name. So, this is available in public domain. So, if you are interested to work on the glacier or snow related research, then you are supposed to refer to this, because this is standard, right. Thank you. I will end the first part of this lecture here, and we will continue this discussion in the next part. Thank you.